right. Good afternoon, DevOps. Welcome to our presentation. We're going to jump right in, aren't we? Imagine you are steering a massive ship through uncertain waters. You have your route mapped out, your course is set, and it seems like everything is under control. But what happens when things change? You thought you planned around all the icebergs, only to later realize, yeah, they are moving constantly. And what about that bad weather or those sea monsters that you could never have anticipated? I believe you all had moments like this in one of your projects, where your plan did not work out the way you thought it would. Maybe you had to completely redesign some parts. Or maybe you employed a more nimble approach, which is all about quick course corrections, fast feedback, and the ability to adapt when nothing is going your way. But how can you be nimble when everyone around you is still working in a traditional way? How can you be the agile crew that guides this big ship through uncertain waters? And that is what we are going to talk about today. And we are Dante and Bart. My name is Dante. I am a technical consultant at AE, a software developer, and of course, as you can see, a public speaker. And you can see a link to my website below.
Yeah. And my name is Bart Jolling. I'm a Microsoft certified Azure solution architect, and I also work at AE, but as a principal consultant. And allow me to quickly introduce AE to you in a few words. We are an IT consultancy firm based out of Leuven. Our motto is we try to help our customers thrive in a digital world, and we do that by applying our holistic vision, by bringing the pragmatic approach and doing everything in co-creation with the client. And for this story, our client is Atrias. And Atrias is a big player on the Belgian energy market. They operate the central market system, which we will call the CMS in the further presentation. And the CMS is a central communication platform that connects all stakeholders in the energy market, from companies generating electricity or gas, transmitting it, putting it on the local network, selling it. All that information flows through Atrias. When we say that we bring our holistic vision, it means that we look at more than just the IT problem. For example, the business case of Atrias was quite complex, and there's a lot of uncertainty there, because there are a lot of stakeholders, a lot of different needs, and they all need to be aligned. So that was one of the challenges that we approached here. The other one was the way of working. Like Dante mentioned, that we were working in a very conservative environment, and Atrias used to work with waterfall, a traditional approach where you have long lead times and long delivery times. And there was a case of a technology that was not quite fixed either. They went from an on-premise mindset with monoliths, package-based solutions, and now we had to do a project in the cloud, components-based, and trying to be as cloud-native as possible. So let's dive a bit into the business challenge. Behind me on screen, you see a typical energy landscape. You start top left with the generation of electricity, the transport of gas, electricity, natural gas that is being put into substations, and then from there it is distributed to the grid operators. The grid operators, they put the energy onto your local network. The energy that they put on the network, you buy it from the retail companies. Think about an Engie, Total Energies, Luminous, they sell energy to you. And that energy ends up in your home. So those three last players, those are the important ones in our context. Domestic users, people like you and me, we have contracts with energy suppliers. And those energy suppliers, they work with the distribution grid operators to put energy on the network. So an Engie, for example, creates their own energy, creates their own electricity and puts it on the network. And the distribution grid operators make sure it arrives at our homes. Now, one of the responsibilities of the DGOs, the distribution grid operators, is to make sure that they know how much we have consumed. So they install meters at everybody's place. And I guess you've all been visited here in Belgium by some installers trying to replace your analog meter with a digital meter, for example. So, and those meters, they generate a lot of data. Let's say we have 6 grid operators, we have 80 plus energy suppliers, and all that data needs to be exchanged between each other. And that's where our client Atrias steps in. because all that data needs to be communicated so that the energy suppliers can create correct invoice. So Atrias collects all that information, and instead of having point-to-point integrations between all the different companies, they have the central data hub where all the data passes on. And Atrias, that's the focus of our story. That's the client that we were working on. Now, Atrias was conceived already in 2011, the same year that Game of Thrones came out. And for some reason, that they killed my favorite character only after 9 episodes already. So that was really a blow. But also, it took a lot of time for the company to just agree on the market implementation guide. The MIG6 documentation defines how different companies talk to each other, how they communicate, what protocols they use, and how they exchange information. So that already took several years. And then it took many more years to develop and test it. And then after about 10 years of development, they finally went live in 2021. And so after more or less 10 years of delivery, they ended up with an outdated system in an ever-changing energy market, because here in Belgium we had gone into the energy transition, going from stable means of production like a nuclear power plant more into volatile production based on solar and wind. And so we ended up with a system that could not cope with this change. And that's something you might have noticed as well, because around that time in the news, stories began to appear about people not being able to switch from energy supplier anymore, people not getting correct invoices anymore. So that coincides with this launch of this system. On top of all that, Flanders had a very ambitious plan to install digital meters at everybody's homes. So a few years ago, they had the goal of having 40% of households installed with digital meters. End of this year, it will be 80%, meaning that in a few months' time, there will be 4.5 million devices sending information to Atrias. And in a few years' time, it should be 100% of all Belgian households sending that information over. And why did they do that? Because Flanders wants to be innovative. They want to enable new kinds of relationship between you, the consumers, and the energy suppliers. For example, so that you might get correct monthly invoices instead of estimated ones based on a yearly reading, or that you can follow the energy tariffs, that you can see now the prices are low, so this is the best time to charge my car, or this is the best time to do my laundry. You will be able to sell your electricity. You can sell it to your neighbor, you can sell to your friends for any price that you would like. So all those kind of scenarios are what they wanted to unlock. So our client, Atrias, was then facing some severe issues. They had increasing volumes. Digital meters, they sent on a daily basis 96 values. A reading every 15 minutes is collected and sent over to the network. As you compare that to the current situation with the analog meters, it was only once a year that you had to enter your values into a web form. And not only did the volumes increase, they noticed that their monolithic application that they installed was not able to cope with these volumes, and the performance went down quite significantly because it took on way too many responsibilities. And the system was very fragile. It lacked any extensibility and nobody really dared touch it. So they preferred to do something on the side of it instead of extending it itself. So if you look at how it was built, it was a centralized monolith. So the center of the picture is the CMS system. On the left, you have all these grid operators sending information over from their meters, like a Fluvius, like you see Belga, even Brussels Airport is a grid operator. And then the system had to ingest all these files, all these readings, validate them, store them in a database, create messages for them, and send them out to the correct energy supplier, like an Engie or Luminous, so they would know who was consuming what amount of data. So the solution that we came up with was not to put all that load again on the CMS, but to take it out and make a system based on data hubs. So all this communication work we pushed it into a data hub, and the only responsibility we left for the CMS was to tell us the link between this meter at this place is being supplied by this energy supplier. And so we could know which data we had to send over to what energy supplier. So, and that's how we attacked the business problem in the most pragmatic way that we could. Okay.
Yes, thank you, Bart. The next area of improvement we would tackle in our project was the way of working. And yeah, it was another key issue for Atrias, since they were always used to working in a waterfall kind of approach, in which they would have these big blocks of design up front, and then later, after years, as you have seen in the timeline, go on to do the implementation. This was a historical choice. It started out in 2010. It was might as well been a norm at that time. And they also explained it to us because they employed it because of their high complexity and there are lots of stakeholders. Of course, when you have a very complex system, it is often useful to think of it in distinct phases so you can tackle the problem one by one. And also for these lots of stakeholders, like the DGOs, the energy suppliers, the entire energy market, yeah, they had to partition them. And a good example is in the testing phase, they had multiple testing phases actually to be able to test with certain kinds of stakeholders. For example, you can see the DIT and the MIT there at the end. That's the DGO integrated testing and the market integrated testing. So they did testing phases for every stakeholder individually. But yeah, the big problem with this approach is the long feedback loop. You can go 10 years, a full decade of development, and in the end come out with a solution that is already outdated by then. And that is what we saw. And you can have like the biggest telescope in the world. You will never be able to foresee every issue that is coming your way. And eventually there will be icebergs. The icebergs will have moved, and you will have to deal with them in that moment. So this waterfall approach was not the way, and we had to introduce our client to an agile approach. The second key issue is that our team was quite isolated from the actual stakeholders we were dealing with. You can see here a typical setup of a Scrum Agile team, and there is a link from the product owner to the stakeholders to be able to understand what this product should actually do. But in our case, this link was not present, or at least very murky. Our product owner did not have any communication with the stakeholders directly, and it had to go through lots of processes. So while you can have the best sailing crew in the world, you need outside communication. You need to know where you're headed, or you might as well be sailing blind. A third aspect was that our team was not end-to-end responsible for the entire software development lifecycle. We often had to throw stuff over the wall to other teams to achieve what we had to do. For example, we had to log like these intricate service tickets or service desk items with our infra team just to be able to deploy a service to production. And also, when our features were finally implemented, the whole thing was shipped over to a testing team from which we would only get feedback months later. So not great to be a nimble team. Lastly, to not repeat the mistakes Atrias made in the past, they put a very experienced architect of theirs into our team. And while he was a valuable team member and, of course, a very experienced architect, he did put some pressure, willingly or unwillingly, on our implementation choices. And the main reason, of course, being you cannot repeat the same mistakes we made, so you have to do it like this, like this, like this. And it's not ideal for an autonomous team to have someone tell you what to do and what not to do.
Yeah, so we have a company used to working in waterfall, doing big designs up front, but we went in there with an agile approach. And because at AE, we really believe that a complex and uncertain project like this one should be handled in an agile way. And what does that give us? It allows us to start from minimal user stories. So we could tell a client, well, already tell us what you know, put it in a story, I will already implement that. And we can go very fast from an ID to some tangible assets that they could then show the stakeholders. As the PO would now talk a bit more to the DGOs and the market, could already show what we had done, how it would work, and they could give their feedback early, and we could integrate it immediately. Working in Scrum also allows us to better track our non-functional requirements, because every sprint we could report on how we were doing in performance, cost, and so on. This required us to coach the client in Agile, because they were not used to it, and they were always thinking in terms of waterfall-driven development. So for coaching, we had to really shake the tree, go up a few layers in management. For example, to make sure that the product owner would be full-time assigned to the project and not just be a part-time analyst like she was in the beginning. So she would get a team of analysts then, and she could fill the backlog up so that we, as development team, could progress at a good speed. We did the same thing for our architectural designs. We also had a separate track together with their Adriel's architect to explore and decide on the architecture on the go and keep that out of the development team as well. So this allows us to build things in a very, very flexible way. We could try out, we could show it worked or it didn't work, and we accept that things might change as our understanding of the problem changes. To make sure that we were building the right thing, we also insisted that the product owner should be involved in everything. So also talk to the internal stakeholders, also talk to the outside world, go and visit DGOs, go and talk to the market and the energy suppliers, and bring back all that information back into the team. So we had the weekly refinements that were dedicated to everything that we learned, to share that with everybody involved in the project. And this gave us early validation and early feedback also that we could work with. And we didn't go in there saying, well, you're used to working with waterfall, this is Scrum, so we will do it now this way and no other way. And we were quite pragmatic in that. We said we go step by step. We'll change what needs changing in a very pragmatic way. We will never block a user story because we don't know everything. We will do it then based on reasonable assumptions. If it changes, it changes. And we will experiment a lot using proof of concepts, using spikes, and that will drive how we will implement our project. So this is how we try to integrate an agile team way of working into quite traditional conservative company. So not only was this a big change in terms of way of working, it was also quite a change in terms of technology. The company came from an on-site monolith package-based solution, but our project had to be done in the cloud, Azure-based, component-based architecture, because they want to explore that, meaning that also for them, their experts were still learning and still getting to grips with this. So when you start with a client, you usually get a big list of requirements that they want to get done. And usually you say to the client, well, you can get it fast, or you can get it cheap, or you can get it very performant. Let's pick two of those. And the client said, no, let's pick all of them. And they came up with this big list. And that really reflects what went wrong in the previous project. If you read this in negative, you can see that the performance of the previous system was not sufficient. We would need to be able to deal with information coming out of 10 million digital devices. The operational cost should be low. It should not be like we have to install huge servers on site and that keep running the entire day, costing money, doing nothing. It had to be scalable, because at the beginning of the project, only a few 100,000 meters were connected, but by the end of the project, we would be in the millions. And that should be possible without having to redeploy everything on the different infrastructure. It should be extensible so that additional data flows could be integrated easily. It should be secure, and it should be maintainable. So those were the things that we took going in when we created our design. And we came up with this high-level design where you see our four main components. In the backend, you have the ingress, correlate, egress, and get message. Ingress takes in all the files, validates that they are technically correct. If they are, we store them in our NoSQL database, and we forward them to the central market system. And that central market system then replies with the link between a meter and the correct energy supplier. And once we receive that link, we can take that information that we received from the grid operators and create messages that we can send then to the suppliers. And those suppliers had two ways of accessing this information. At the right in the middle, you see a SOAP XML get message service. That was still the old traditional XML-based way of working. Many of the suppliers had heavily invested in XML during the conception of CMS, so they didn't want really to change that. So they could here, one by one, get their messages if they pleased. But we also allowed a second path to get the data, and that was through the egress component, where we had a way smaller and more lean message that they could use to get to their information. And besides that, to monitor everything, there was a web application that allowed internal, external operators to monitor what the system was doing. Grid operators could see where the files were going, energy suppliers could see where the messages were coming from, and the internal staff at Atrias could intervene in case of incidents in the system to restart the process. So what does it technically look like? What technical choices did we make? At the left, you see the infrastructure that was being put in place by Atrias while doing their transition into a more cloud-based infrastructure. There was a managed file transfer service. There were the firewalls. They had their API manager, their Active Directory, and we plugged in right into that ecosystem. In the center, you see our boundary. So we allowed files to come in and go out through storage accounts. We had the BFF, that was the backend for front-end for the UI, and we had the get message service, the SOAP XML service that the suppliers could use to get to their information. And in the back, everything was done with Azure durable functions. Those durable function apps that are Microsoft's serverless compute units. So they get triggered when something happens in the system. A file arrives, and that creates an event grid trigger that then triggers an Azure function, and that function can pick up the file, do its processing, create a new file, which generates a new event that can be picked up by the next Azure function. And we took that same pattern everywhere. So even if we had an action coming from the BFF or jobs that are scheduled, we also did them through event grid events. So that was the only way that you could start a process in these functions. And in the backend, we use Azure Cosmos DB to store documents, and we use a SQL Server to store messages. So in the end, I think we ended up with an architecture that really fulfilled all the requirements. It was loosely coupled, it was scalable, it was pay-as-you-go. Azure functions, they scale up when there's a lot of work, but they scale back down when there's nothing to do, so you don't pay for them. And as we plugged in into their secured system, we were also secure by design. So that's one thing of coming up with a nice and performing architecture. But how do you make sure it keeps that way? Because you make now decisions, and those, as you know, might be hard to change. An architecture, once decided, is not that easily changed anymore. But as things evolve over the years, so will your architecture need to change. So how do you decide on what you change and why? And that's why we looked at evolutionary architectures. So an evolutionary architecture, that's an architecture that supports incremental guided changes across multiple dimensions. And the keyword for me here is guided. So you don't just change what you think might have a good impact, but you put in place metrics, KPIs, you observe the system and you see where the bottlenecks are, for example, in performance, and you tackle those. One of the key techniques that evolutionary architectures propose are fitness function-driven development. So for all non-functional requirements that you want to achieve, you define what means success, you define what means being fit, and that's your function then that will say yes or no, this architecture is fit for your purpose. So you define that upfront, and then you set in place a short feedback loop so you can immediately get a feel of if you're still in line with your non-functional requirements. That can be a process, that can be monitoring, that can be automated tools in your pipeline that will tell you you're still doing well or not. Because many projects that I've worked on, they would just do the unit testing, they would build and deploy, and they would do their integration testing, end-to-end testing, and then be happy. That's good, we have done everything that we needed to do. So now you can promote to production, right? What the fitness function-driven injects is an additional step in between. So automated checks if everything that you're about to deploy is still in line with your non-functional requirements. Checks on code quality, checks on your security, checks on your performance. And you try to automate as many of those as you can. We used, for example, Sonar Cloud for code quality, Snyk for security, Azure load testing to load the system and see what happens if you can keep up with the speed that is required. And only then, when those tests are successful, then we promote it to production. I can give you a nice example of how we use this guided changes for the performance fitness function. On this slide, you see evolution of speed, items per second, over 5 sprints for the 4 components. You see ingress is quite stable, correlate suddenly drops, loses 60% of its speed, messages are a bit fluctuating up and down, and the egress component goes from 200 items per second to over 500 items per second. What happened there? So we were constantly measuring the performance of all these components, and we noticed that if the egress component can only do 200 messages per second, we will never achieve the goal of delivering all data by the end of the day to the correct energy suppliers. It is too slow. And that's why we decided to move the on-the-fly generation of messages out of that component, and we put them in the correlate component. And immediately the correlate component lost 60% of its performance. But that's not really an issue. The correlate component was something internal. Nobody will really be affected by this. But the egress component, that's something that is publicly available. Stakeholders, like people in the energy market, will see that. So we sacrificed performance on one component to gain in another one. And we did the same thing for scalability. During every load test, we measure scalability, and we could always prove at the end of the sprint, see, it is scalable. We start out from 1 instance, scales up to 5 during this 2-hour period of load, and then scales back down to 1 instance. And even for cost, we did the same. But it was automated in Excel, so there's no other tool for that for the moment. So we could choose which options would be cost-effective on the long term, and then we go forward with this. So that's all nice to have this big vision and this big processes in place, but how do you implement this?
Yeah, well, this means we need to go deeper, right? We need to get into the nitty-gritty details of our implementation. And if you're only here because the last sentence of the talk in the summary said something about technical, geeky stuff, well, then this is your moment, and if not, bear with me here. So our evolutionary architecture, our way of working, because of all these practices we put in place, we could actually go above and beyond in this project if we wanted to. We could actually use our modern approach in this project, and we could install a brand new engine in this traditional ship. But for that, we had a few focus areas in which we focused on to really bring the modern workflow in them. One is version control. We practiced trunk-based development, in which our main branch was always shippable. So this is really continuous integration at heart, only short-lived feature branches. And this allowed us to work with release branches. Now, why was this important in our case? Our client had a lot of different environments. And if we would have had branches for every one of those, it would become a complete mess. So we decided to just go with a release branch, version them properly, and then promote this release across all environments. And it doesn't matter if we have 4 or 20, this can just work. This ties neatly into our CI/CD pipelines, moreover our release pipelines, because there we can employ the same strategy. We can build our dev environment from our main branch, for example, but our higher environments are built off these release branches. And you can see an example of our pipeline strategy over here. Also for testing, we did a quite interesting approach. Let's start with the tests we write as developers. So developer tests, I named them here. And of course, we wrote a lot of unit tests. These tests are programmed for correctness. It's vital that they are there. But we also employed a technique called snapshot testing. Because we had processes that often produced big outputs, we didn't want to write 100,000 assert statements everywhere to check that every field is filled in correctly. So we employed this technique. And in short, it just compares the output that you have set as to be the truth with the output that the test generates. If they are the same, they look the same, it's the same XML structure, then sure, the test will pass. If they are not the same, then we look, is this an intended change? Then we accept this new output as the new truth. Is this an unintended change? Well, then we have some bug fixing to do. So this is a really interesting technique if you have lots of output and you want to be able to test quickly. Also for integration testing, we had an interesting approach. Because our process made heavy use of complicated SQL queries to do multiple things in one transaction, because we want to be very performant, we had to find a way to test this interaction with SQL, to test these queries in a real environment. And the issue with unit testing is you would just mock away all this complexity. But with automated integration tests using test containers, you can spin up containerized versions of your database, for example, run your tests, they will manipulate data in this container. If everything passes, great, we just destroy this container and all the data with it is gone. And this makes your integration tests very isolated, and this also meant we could run them in parallel throughout our CI/CD pipeline without any issues, without any data leaking to all over the place. Then Bart already mentioned load testing. I just mentioned it here. We did that in Azure load testing with the JMeter scripts, and it helped us keep on track with our performance goals that we set out from the start. Also from end-to-end testing, you've seen this conceptual architecture before. We made it very extensible. We made it very loosely coupled, and this way we could just swap in and out components. Our dependency on this central system, we didn't want that in testing. We wanted to test a lot of scenarios very quickly. We just wrote our own CMS stub, we called it, that could just respond with all kinds of different scenarios that we might see from the actual CMS. So this meant we could also test unhappy flows whenever we wanted. And also for input files, we had a test file generator that could generate all kinds of different input data to really test our system, how it would respond. So no longer would we have to craft manual XML files and introduce stuff. We can do it automated. As for our cloud infrastructure, we really leaned into the cloud native aspect, and we used a lot of off-the-shelf Azure components. We didn't want this solution to be very complicated. It should be maintainable, and every developer should immediately know what's going on. So we chose components from Azure for this. And they were all managed using Terraform infrastructure as code. Because again, we had a lot of environments. This meant that we could just define how our cloud landscape would look like, and the environments would just be a configuration file that would tweak some parameters or maybe turn certain services off or maybe put the scalability on production way higher. But when a newer environment came along, we just add a configuration file and everything would just work. Also for our user interface, we had a lot of different and interesting approaches. Our client initially just wanted a read-only monitoring front end with which they could just see some numbers and the processes that are running in the background. But when iterating in this agile way of working and when asking them for feedback, they kept coming back to us with more requirements, as it usually goes. But in our case, we were really happy. We could show them why they chose us in the first place. And we really envisioned a zero support mindset for this UI. Maybe you had a project that was going into maintenance mode, and yeah, the maintenance team asked, "Can we execute this SQL statement on your database to get some stuff right?" This is what we wanted to prevent. No longer did we want them to do API calls to us. It should all be manageable from this UI. This is a screenshot of our UI. It's a pretty big screen, but it's quite small. In the bottom right, you can see some buttons that support agents could actually take action on these jobs that were running. So they could resend certain files to stakeholders. And if this job would have failed, they could push the retry or the discard button and handle these jobs that way. Lastly, one of the changes we made is a new data format. I'm going to show you the old format first. What is the content of this format? It doesn't really matter, but I want you to pay attention to the vertical scroll bar. It is a very big file. In these like 60 lines of document, we have not seen a single digital meter reading yet. It's all just envelope, ceremony, overhead. And for internal use, we made our own format. And it looks like this, and you can see in these 50 lines, you already have 38 lines of actual data. Okay, but this left file was a standard imposed by the energy sector, and so yeah, we had to support this, but we thought, why not also export the lean format to our end users? And some energy suppliers actually made the change to work with this lean format. They put in the effort, and they gained a massive performance benefit because they were not hauling gigantic files around. So to conclude, we really went above and beyond on this project. We tried to really put the modern engine in this traditional ship. But as every software developer, consultant, whatever knows, you can't win them all. There's always going to be need for the old stuff to stay. And in our case, that was in two main areas. The client had had bad experiences in the past, and there were some really heavyweight standards we just could not change. One experience of these bad experiences, one example, rather, of these bad experiences in the past had to do with batch processing versus event-driven, event-based processing. Batch processing, you just have some files, you process them, you send out output files, everything is great. In event streams, you will chunk these files into their individual components, handle them distributedly throughout your system using events and event queues. We opted for the second approach. We wanted this really bad, but our client said, yeah, no queues. It's not happening. We asked them why. We explained our vision. No, we had queues in the previous project, and everything blew up, and we don't want queues anymore. Yeah, we conceded that point. We went with batch processing, with a job-based, file-based approach, and we made it work behind the scenes then with events internally. But to the outside world, no queues. Also, XML, SOAP, big data formats. Those were non-negotiable because the investment had been made 10 years ago for this big standard. And yeah, that's not possible to change that. So that wraps up the technology part. And then that also wraps up our trifecta of uncertainty, to say. A very complex business, lots of stakeholders, lots of standards, lots of traditional practices. A way of working that is not future-proof and that needed tweaking and a lot of coaching from our end to the client. And a technological challenge because of the many non-functional requirements and the complexity in that. But in the end, our ship arrived safely to the harbor. 1 year ago, we had a very smooth go-live with the team without any noteworthy issues. And still to this day, the system has been running constantly without any major interventions or any major changes, while the load has more than doubled. So our future-proof thinking really paid off already. Despite the limitations, our team made a big impact, and we coached our client along the way. We didn't just set this system in place and disappear. We really took them along. We introduced agile way of working. We showed them how the technology in the cloud could actually work. And needless to say, they were very happy about this approach. So we went from uncertainty, not really knowing what the client wanted, to exploration. We did some experimentation, did some proof of concepts. Also went into the iterating phase and really worked along with the client, kept changing stuff, asking quick feedback, making adaptations. And that gained us confidence, and momentum just kept going. But this was not a linear process. We were often catapulted right back into uncertainty when some things didn't go our way, or we had to do some more exploration or some more experimenting. But in the end, the most important part, we went from this uncertainty to success. And we thrived with a modern approach in a conservative environment. And that brings this story full circle. Thank you all very much for your attention. And if there's any questions, feel free to ask now or later. Thank you.
Thank you.
Thank you.
All systems are nominal. Initialize Genesis sequence.